Hi. So I will be talking about blockchain. So I'm not going to be talking about whether you can make money on Bitcoin. I'm talking about the actual technology of how blockchain works. So what is it exactly? And there's just so much hype. There's all these articles about how whatever it is the biggest advancement in technology since the internet, or it's being considered for all sorts of problems like IoT and voting. And my absolute favorite, because I'm sort of known as the skeptic, the blockchain skeptic at Dell, people send me all these articles. And so my favorite one said, it's being considered by the US military for, they're looking at blockchain technology for securing our nuclear weapons. So it's very hard to get information on exactly how the technology works, and that's what I'm going to talk about. How does it work, and what are its actual properties? So, what is it? So it's also getting to be less and less well defined. So when I complain about certain technical aspects of it, they say, well, that can be changed. Well, if you can completely change it, what about it is intrinsically blockchain anymore? It's not very well defined. So, I've seen it applied to basically any redesign that includes computers, networks, and crypto, in which case I've been doing blockchain my entire career. So it's really impossible to know what a generic blockchain technology is, but it is possible to describe the technology behind Bitcoin, because that's sort of well defined, and that's what I'm going to be focused on. So Bitcoin was a paper in 2008 written by presumably a pseudonym, and it was released as open source software soon after. And the community, the open source community, agrees on modifications. So the details might change. There's really no spec. It's just the code. And if there actually was a spec with lots of independent implementations, it would be a disaster, as we'll see in the talk. So the main design goal for this, which actually led to a very interesting design, whether or not it's applicable to basically any other application is certainly arguable, but the main design goal was, let's not trust any known organizations. Sort of an anarchist kind of viewpoint, to prevent governments from doing things like enforcing, collecting taxes, following a money trail, preventing you from sending money to terrorist organizations or whatever. And whether or not these are desirable goals, this does lead to an interesting technical design. So the trust model here is that instead of trusting a bank or a company or a country, a trust is given to a large community of anonymous, what's called miners. Anyone can be a miner. You can just download the code and start doing it on your own machine. Miners are rewarded based on doing a lot of computation, and I'll explain why it's a lot of computation and exactly how big a lot is. And the assumption is that the set of honest miners will have more compute than anybody else on the planet can compile, which is kind of a very weird assumption. So you could also, instead of downloading the code, you can actually go to Amazon or some other company, presumably, and purchase a special one of these rigs that does the hashes very quickly. So Bitcoin, there's this log that records every single event that has ever happened. So every time anyone has ever bought a cup of coffee, it's in the ledger, and you have to keep the ledger in its entirety in order to make sense of it. Every transaction looks like some payer paid somebody else some amount of Bitcoin, and the payers and payees are public keys. So that's what a transaction looks like. Public key X pays public key Y some amount. So the format of a ledger is as a chain of blocks, which is where they got the term blockchain. And each block has a hash of the previous block and a bunch of transactions and a random number known as the nonce. I'll explain why you need that, and the public key of the lucky miner that was able to create this block. Each item in the ledger says, a transaction says, from some previous transaction which has a certain hash, I am paying this other public key the output of that. So in this case, if you notice, the third line says, from transaction X15, that was where A was paid 74.92, A is now paying C 74.21. And there's a difference there. That's a transaction fee, and the difference there is paid to the miner that finds the block. So what's a ledger? It's a scary word that sounds, there must be something revolutionary about this stuff because people say it's transformational. Is having a ledger a revolution in something? It's just a append-only log. And most systems actually, like file systems, have a log that goes along with it. But here it's an append-only log that must be kept in its entirety since the thing got invented. Lots of storage systems also have logs, but usually you can discard the log data older than some amount, more than a year old or something. It's there to find out who did some bad thing, but once you assume that you don't need to know anything that happened more than a year ago, you can throw that away. There's also distributed database technology, which is far more sophisticated and flexible and has more features than just an append-only log. It's where a bunch of different nodes can all touch the same data. And so, therefore, you need to do sophisticated things like locking things because you need to do several things, and or atomic transactions where you want all of these things to happen or none of them, in which case you do two-phase commit. But this ledger thing is just an append-only log that must be kept in its entirety. So what's a valid transaction? So suppose you are B and A pays you some Bitcoin. So A is going to pay you the output of some previous transaction. How can you tell if you're actually going to be paid? Is this transaction valid? So you have to find the previous transaction where this transaction where A pays you has to be validly signed by A's public key. But then you have to find some previous transaction with that hash in which A was paid that amount. Otherwise, and then you have to search all the transactions after that to make sure that A hasn't already paid that to somebody else. So, and until the transaction is solidly in the ledger, and I'll explain what that means, A can double spend and cheat you. So if you are the merchant and A is paying you, you kind of know whether you're being paid, but it's not quite as simple as you might think. But what about the customer? You pay somebody and they don't ship the stuff. What recourse do you have? eBay, you can complain to eBay. Amazon, you can complain to Amazon. But here, there's nobody in charge. I sort of like having adult supervision where there's some, most applications require some adult supervision. Now, if there were a central thing like a bank, having a definitive ledger would be trivial computationally and could be made very secure, and there's someone who can mediate disputes. And you can sue it if it misbehaved. Or you can have a consortium of several known organizations. And again, with traditional technology, you can do a far better job than basing it on this technology that was designed specifically for this kind of anarchist model where no known organizations are inside. And if you're worried about a misbehavior of some minority subset, you sort of force any a quorum of them to sign off on something. And compared to blockchain, as we'll see, this is way more efficient in terms of computation, bandwidth, storage, and latency, and it allows the adult supervision that most applications require. So going back to Bitcoin's blockchain, if you have no known organizations, where do Bitcoins come from, and how is the ledger agreed upon? So the blockchain is a set of blocks where A new block is a set of new valid transactions whose cryptographic hash is extremely hard to compute, and I'll explain why that is. Bitcoin tries to cause a block to be added to the chain about every 10 minutes. So if blocks are added more quickly than that, they adjust it to make the hash harder to compute. And if it's too easy, they'll make the hash easier to compute to try to hit that spot of about 10 minutes. Now, what's a cryptographic hash? It's sort of like a random number that given any input, the output looks kind of random. So if you wanted to have an input that you throw in a random number or something, and you want the output to have the top bit be 0, you have a 50% probability for any particular input whether the hash will have the top bit be 0. If you want the top 10 bits to be 0, then you have a 1 in 2 to the 10 chance. So the maximum winning hash value is what is adjusted to make it easier or harder. And currently, the hash has to have 71 leading zeros. 2 to the 71 is such a mind-bogglingly astonishing number. So how do you find a block with a hash with 71 leading zeros? You insert a bunch of valid transactions. You choose a random number for the nonce. You compute the hash. If the hash doesn't have 71 leading zeros, which probability of 1 minus 2 to 1 over 2 to the 71, it won't. Choose a different random number and repeat this about 2 to the 71 times. If you're lucky enough to be the first to find a next block with a small enough hash value, you get rewarded with some number of bitcoins. So currently the reward is 12.5 bitcoins plus any of transaction fees in any of the transactions. Now, what's the purpose of all of this hashing, which is estimated to be 6 times 10 to the 18 hashes per second? Again, these numbers are things that just you can't grok. You know, anyone can be a miner. So again, the assumption is that they've cornered the market on compute. Nobody else will ever be able to assemble as much compute as this community has. Suppose a set of miners had most of the compute resources. They could undo transactions and create an alternate history. They could discriminate against certain transactions and refuse to ever put them in the ledger. They can double spend their own money by making the merchant think that it's in the ledger and then backing up the ledger. And this would bring down the whole Bitcoin concept if anyone actually bothered to do this. So this, you know, is what blows my mind as sort of a cryptography person. Let's look at an integrity proof. With blockchain, there's no secrets. So by design, creating that hash is very expensive to compute. And they're thinking it's so expensive to compute, no one will bother trying to compute an alternate one. Whereas with traditional cryptography, like public key stuff, the trusted entities know a secret, like a private key, and it's computationally very simple for them to create a signature, but computationally enormously much more expensive to forge if you don't know that secret. So with my terminology of a good guy is someone that knows the secret, they're authorized to do it, a bad guy is someone trying to forge it. With traditional cryptography, there's an enormous gap between the compute necessary by the good guys and the bad guys, and increasing the key size makes the gap bigger. So for a 1,000-bit RSA, forging the signature is about 2 to the 63 harder than generating a signature, but with a 2,000-bit RSA key, forging it is about 2 to the 94 times harder, whereas blockchain is equally expensive to compute as to forge. Now again, 2 to the 63, 2 to the 94, I've been trying to figure out how to make this understandable. So another way of saying it is with RSA signing versus forging, if you use a 1,000-bit key, signing takes about 1 millisecond on a typical CPU. And if you double the size of the key to 2,000 bits, signing takes about 6 milliseconds if you know the private key. But breaking 1,000-bit would take the entire current Bitcoin miners community computation for an hour, but if you double the size of the key to 2,000 bits, breaking a 2,000-bit RSA key would require the compute power of the entire Bitcoin mining community for the next million years. So as opposed to with blockchain, where it's equally expensive to create as to forge. So it's mind-bogglingly expensive and insecure, because this assumption that they have more compute than anyone else is just not true. So I claim that the fundamental novelty of blockchain is having an integrity proof using no secrets and no known entities. I claim the novelty isn't that you have data formatted as a chain of blocks, append only, or data stored in lots of places, or multiple cooperating nodes maintaining a database, or having an integrity proof on the data, making it immutable. Now, immutable, that means unable to be changed. Is the blockchain immutable? No. With an integrity check, in theory, you can change the data, but with an integrity check, you will notice that it's been changed. But wouldn't it be better to have an integrity check that is enormously more difficult to forge as to create than this other stuff? And more dramatically, someone can decide to roll back the ledger, and I'll talk about reasons and how this happens. So I'll talk about temporary forks, unintentional forks, and intentional forks. So what's a fork? Well, you have two different chains that are both valid. In this case, that's a valid chain, and this is also a valid chain. So how does that get resolved? Well, it is possible for multiple miners to semi-simultaneously find the next block, because things don't happen simultaneously on the internet, which means the blockchain will fork, and this happens all the time, actually. If a miner sees multiple chains, it will work off of the longest one. So with any luck, it will all resolve itself. But this can take several blocks. So the advice is, don't consider yourself as definitely being paid unless you see your transaction recorded in block N, and there's 6 more blocks after that. So that's like an hour. So if you buy a cup of coffee with blockchain, should the coffee company keep you there for an hour to make sure that it really will wind up in the ledger? So a temporary fork, if the internet were partitioned, or if the gossip network were partitioned, like the way that these stuff gets around is everyone's configured with certain addresses, and it could be that 1 or 2 guys are really on the cut set between, and if they go down, then nobody on the other side hears about it. So if there's a partition, miners on either side will happily keep creating the chain, and this can go on way longer than an hour. It can go on for days or whatever. When the partitions rejoin, then whichever one is longer will win, and the other one loses, which means any bitcoins that got mined by well-meaning miners at that point, their money goes away. Any transactions in the losing fork are no longer in the ledger, and any payers in the transactions in the losing fork can respend their money if they do it quickly. Now, another thing is kind of an unintentional fork that could have been permanent. So as I said, if there were multiple different implementations with subtle differences, you'd be really in trouble. And this actually happened in 2013, where they upgraded the software in such a way that there was a transaction that looked valid to the new software, but the old software thought it was invalid. So when you sign, when you build on a blockchain, every transaction in there has to look valid to you. So the old guys were ignoring the other chain because there was this transaction in there that they didn't like. So this would have gone on forever until somebody noticed and then had to make a decision. And so they chose that they'll go back to the older version, which meant that there were days in which people had thought that they mined money, thought that they were paid, and that transaction just sort of completely went away. So that there's never a point at which you're guaranteed that something will actually remain there. Another thing was an intentional fork. So Ethereum is sort of copies the same technology. And one of the things they do is what's called smart contracts, where they say, we don't need no lawyers. We will write the rules in code, and the code speaks for itself. So somebody did some sort of code for, some sort of organization. They called it a distributed autonomous organization. And the code spoke for itself. And so people invested in this, real money. It was like $150 million worth of Ethereum. And then somebody realized a feature or a bug in the code where he could create a subsidiary and move the money to himself. So he managed to take tens of millions of dollars into his subsidiary. And so then they had to decide, well, wait a minute, do we really believe that the code speaks for itself, or do we undo this? So weeks later again, they decided, okay, we're not going to let this guy get away with it. And so they rolled the ledger back, which meant that, again, other than this one transaction, there were people that thought that their things were, that they had mined money and thought, and they rolled them all back. So supposedly there's no one in charge of the blockchain, and it's a completely democratic group of anonymous miners, but somebody, sort of has more clout and can convince the others. And I would rather that whoever it is that's making these decisions was a big company that you can sue or whatever, rather than, the political climate in this community. So there's finite total bitcoins. Initially, the reward for finding the winning hash of a block was 50, and every 4 years or so, they halve it. So it was 25, and now it's 12 and a half. And eventually, the reward will be zero other than the transaction fees. But long before then, it'll be negligible. It'll be like, hundreds of cents or whatever. So Bitcoin claims that it has lower transaction fees than, for instance, credit cards, which today is true. But once, once you have to depend solely on the transaction fees, currently it's about $8 per transaction, and the miners barely break even in terms of electricity. So it's no longer going to be cost effective to try to buy a cup of coffee with this. There's interesting statistics on the web, and the statistics in my slides may be out of date, but they'll give you an idea anyway. Now, another concept is full nodes versus lightweight nodes. So the original design, if you wanted to accept money, you'd have to have the entire ledger and do all this stuff of searching for the transaction and searching all the previous ones. But your smartphone isn't going to do that. So you're configured with some full nodes that keep track of all of this, which means that supposedly nothing needs to be trusted, but clients have to be configured to trust the nodes they're configured to trust. So how much energy is being consumed by this? So basically, the estimate, given that the miners barely break even on electricity, if you work out the math, the miner reward in total is about $2 million a day, and this is about enough electricity for 500,000 American homes, or about a nuclear power plant. So even, with it being kind of this small researchy thing, we're consuming a nuclear power plant on this stuff. But I claim that estimate might be low because of psychology. If you buy a mining rig, you're going to want to use it, even though you're losing money on electricity. Or you may not know how much the mining is costing you. How carefully do you look at the electric bill? Or if somebody else pays the electricity, you don't care. When does that happen? Well, bots, where you break into machines and have them mining for you, or you live in your parents' basement, and you're not paying the bill. So it's harder to win against the specialized machines with the software thing, but if the electricity is free, hey, why not? How much storage? Well, currently the ledger is 126 gigs. And it grows about 40 to 50 gigs every year, especially now when they've increased the block size, it's going to grow even bigger. And that's being kept at every full node. And no one knows how many there are, but there's at least 6,000 and possibly as many as 30,000. And well, you know, I work for a storage company, so hey, I guess that's all good. But so it's also hard to protect your Bitcoins. It's just data on your machine with all the private keys you use. If you lose that data, all the money is gone. Or if your computer is broken into, your money can be stolen and spent by somebody else. With banks, there's some legal protection. And so there's a lot of confusion because people are calling all sorts of things blockchain. They might even be totally reasonable technology, but they aren't revolutionary and they aren't Bitcoin's blockchain. So what makes them blockchain technology? And I don't have a clue, you know, where the boundary is between. Now, there's private blockchains where one or several well-known organizations manage the data, and it's really just an API for store data and read data with a black box that does blockchain, whatever that is, and lots of applications can use it. And so I go to talks where they say, look at all the applications, but they also could have used a cloud or VNX or a hard disk. So people assume the black box provides immutability and low latency and security. These are just not true. And if the organizations are known, just use public key signatures. So Rand, people show how you can do things with blockchain, like for instance, timestamping, but just because you can do something with blockchain doesn't mean that it couldn't have been done before, and it doesn't mean it's the best solution. So my advice for designs is don't say, you know, please start with what problem am I solving, look at it, different alternatives, instead of saying, what can I apply blockchain to? Yeah, it could be that the hype is sufficiently successful that calling things blockchain might be the right thing to do. And I don't care what you call things, I just care about the security and efficiency property of technologies. So, okay, that's it. Thank you very much.